Hello student, my name is Kalal from Alja Institute of Engineering and Technology. So today I discussed psychometric numerical. Okay, so psychometric numerical based on psychometric chart. Okay, so first problem is 50 meter cube per minute of air at 30 degrees centigrade dry bulb temperature and 20 degrees centigrade wet bulb temperature flows through a cooling coil whose surface temperature is 5 degrees centigrade. The coil cooling capacity is 3.5 ton of refrigeration under the given condition of air. Determine dry bulb temperature, wet bulb temperature of air leaving the cooling coil, bypass factor and water condensed at coil. This is the best numerical. Okay, so we can understand this numerical. Okay. So what he asked, first air which comes into contact with the coil. Let's understand first. This is our air, comes with 50 meter cube per minute of air, and this is our coil. Okay, so air temperature, there is a TD1 is a 30 degree dry bulb temperature centigrade, and wet bulb temperature is TW1 is equals to 20 degrees centigrade and flows through a cooling coil. The coil is cooling. Okay, cooling coil. Coil is cooling. So temperature is cooling coil is TD3 or sometimes it written as a TA. Okay, whose temperature, coil temperature is given, that is a 5 degrees centigrade. Okay. The coil capacity is 3.5 TR. Ton of refrigerant. The capacity is given, that is a 3.5. That is a 3.5 ton of cooling coil capacity. That means 3.5 kilowatt ton. Ton is converted into kilowatt. So multiply 3.5 into 3.5 because 1 TR is equals to 3.5 kilowatt. As we know in the refrigeration, in first lectures of RAC subject, there is a 1 TR is equals to 3.5 kilowatt. So here capacity of coil is given, that is a 3.5 TR. So total capacity is 3.5 into 3.5 kilowatt. Okay, that is capacity, that is the amount of heat can absorb by this cooling coil. After that, this cooled air supplied to the condition space. There is a condition space, or we can say room. Okay, so calculate dBT, that is a TD2 of this air, and dry bulb TW2 for this air. Okay, this is just forward. So calculate these two things and bypass factor also and water condensed at coil. First, now locate point 1 and 3 according to given condition on psychometric chart. So just I give brief idea. First of all, locate in the psychometric chart. How to locate? So this is suppose our psychometric chart. This is our psychometric chart. Point number 1, condition of point number 1 is a given. Condition of point number 1 is a given. This is a 1 point and this temperature is given, that is a 30 degrees centigrade. And point number 3 is what? Coil temperature, which is given 5 degree, and coil temperature which is given 5 degrees centigrade. Okay, 5 degree centigrade. Locate these 2 points and we obtain a value H1, H3 and V1. So how to calculate H1, H3? So H1 is corresponding here and W1 is at here. Okay, H1, H3 and 3 point, that is a 5 degrees centigrade. This is 3 point and 5 degrees centigrade is given. This is 5 degrees centigrade. Okay, so calculate here H3, that is the coil temperature. Okay, this is our just idea. Okay, so specific volume is also calculated. So both this value. Now mass flow rate of air. How to calculate mass flow rate? That is the M is V1 divided by V1. V1 is from this one. This is our V1 small. A capital V is given, that is the flow rate is given, that is 50 meter cube per minute. So put this two values and we obtain 57.21 kg per minute and converted into kg per second, that is a divided by 60. So we obtain 0.9535 kg per second. Next is cooling coil capacity. So QC is equals to M H1 minus H2. H1 minus H2. H1 minus H2. This is capacity is given, that is 12.25 is equals to 0.953557 minus H2. So we obtained by cooling capacity H2 is equals to 44.15, because we don't know the point number 2 exactly where is it in psychrometric chart. That's why first calculate any one data related to point number 2. That's why we use cooling coil capacity, that is a Q. Cooling coil capacity is nothing but the amount of heat remove capacity from the conditioned space, okay, from the air. So QC M H1 minus H2 we apply and we put all the data and we calculate H2, that is a 44.45. Now locate point 2 on the psychrometric chart. Point 1 and point 3 we already located, okay. So point 2 located, which is in the line, because we already locate point 1 and 3 already located. So where is point 2? We know that point temperature of point 2 always less than coil temperature, because bypass factor is calculated 1 to calculated. That's why point 2 is lies in here, because H3 enthalpy of H3 already we calculated and H1 enthalpy. So H2 enthalpy is where H2 is enthalpy is 44.15. So we can draw point 2 and corresponding point 2 we can calculate the temperature of point 2 also. First enthalpy which cross this line 1 to 3 line, okay, and then we calculate the TD2, that is 21.4 degrees centigrade, and TWB weight bulb temperature 15.6 degrees centigrade, and specific humidity 8.2, that is 8.9 gram per kg of dry air. This all the values from psychrometric chart corresponding to this enthalpy, okay, corresponding to this enthalpy, okay. And bypass factor, now we calculate bypass factor. Bypass factor we apply formula bypass factor of cooling coil TD2 minus TD3. What is TD3? TD3 is nothing but coil temperature, is a coil temperature TD3, and TD3 we put all the values and we calculate bypass factor, that is a 0.656 bypass factor is obtained. Next is condensate flow or water condensed at coil, because we use the cooling coil, the amount of water which is condensed because of humid air comes in contact with the cooling coil. So that time amount of water vapor that condensed at cooling coil and it comes out from the return pipe. That is we use formula MW, and condensation due to change in specific humidity. Already we know that condensation due to latent heat, concept of latent heat, MW is equals to mass of water supply, that is W1 minus W2. So we already know that W1 and W2 value, put this value and we calculate the mass of water that is condensed on the coil, that is 0.0018 kg per kilogram per second or 0.108 kg per minute, okay. So in this chart, this is our psychrometric chart, we locate all the points, okay. First point is a 30 degrees centigrade. Just understand, we given data is 50 meter cube of air and 30 degree DVT and WBT 20 degree. So how to locate point number 1, okay. In this chart, point number 1, how to locate? This is our point number 1 located in this numerical in this chart already. So we have a 30 degree line, okay, 30 degree C in the here. This is our 30 degree. Draw this line up to straight, and weight bulb temperature is always inclined. Weight bulb temperature always inclined line. This is our 20 degree weight bulb temperature line. These both line intersect at this point. So that's why this point number 1 located, okay. This point number 1 is located, okay. This is point number 1, and we locate, we see the dew point temperature of entering air. First we check dew point temperature of entering air, so that we can say that coil temperature is on the saturation line, By first we check at point 1 what is dew point temperature. So dew point temperature line is always horizontal line, So at point 1 corresponding is 15 degrees centigrade dew point temperature. So what we do next? And our coil temperature is 5 degree. Our coil temperature is 5 degree. So 5 degree coil temperature is less than 15 degree. That means this is the ADP, apparatus dew point temperature. That means dehumidification process occurs. Dehumidification process occurs. That means W is reduced because coil temperature, coil surface temperature is less than dew point temperature of entering air. That means is the process of dehumidification. We can already by this numerical we understand how to dehumidification occurs. If so, this is a method of dehumidification. Understand? If your temperature, coil temperature is less than dew point temperature of entering air, that means you have dehumidification. You do dehumidification. Okay, so 0.3 lies here, that is a 5 degree centigrade. 0.3 lies in, that is a 5 degree centigrade. And now, so we calculate H2 by using of capacity formula. Q is equals to M H1 minus H2 capacity formula. Capacity is given 3.5 TR into 3.5. So H2 locate 44.15, which is in numerical, and draw a line from H2 that is a 44.15, which intersect at 13 line at point here, and we calculate TD2. We calculate TD2 and also calculate here weight bulb temperature and humidity of entering room entering air, that is a W2. So according to this psychrometric charts, we can calculate all the parameters without any calculation. Okay, so I hope you understand this chart. Thank you so much.